Good morning. Good morning. You're welcome to our today's class. Please, can I have marker, please? Today, we'll spend the first 1 hour for BD 253. So if there is still time, we'll spend the next 1 hour again for our AUM. Remember I told you that I have topics across these courses. So today we are starting. We've done our introduction on BD 253. So today we are starting with the first topic. Numbers and numerals. I hope you've all seen the lecture materials, and I hope you've studied up to the fourth topic by now. If you have not, you are already lagging behind. If by now you've not gotten up to the fourth topic and solved all the questions there, then just know that you are already what? Lagging behind. So you better speed up. So let's start with numbers. So what is a number? Any idea? You did mathematics in your primary school, nursery school, primary school, secondary school. So what is a number? Who can define the term numbers for us? What's a number? Huh? Nobody. Are you serious? Huh? What's a number? Number is a digit. Thank you. What's a number? So a number is a digit. Uh-huh. It's also a digit. Thank you. What's a number? Digit. Wow. What's a number? Digit. Okay, now. What's a number? Huh? Hey, wow. What's a number? Okay, now. What's a number? Hey, they want me. Are you serious? What's the number? What's the number? A what? Figure. Okay. What's the number? Digits. Okay. What's the number? Figure. What's the number? Figure. What's the number? This girl will go far. She has already started doing something. Others are still playing. They play. What's the number? Digit. Okay. What's the number? Huh? Figure. It's a mathematical concept. That does what? Continue. You started well. Continue. That does what? Figure. Figure. Stand up. Tell us more about number. You said that number is what? Okay. Counting and what? Measurement of quantities. God bless you. Please clap for her. Clap for her. Keep clapping. Keep clapping. It's okay. It's okay. It's okay. Thank you. Thank you. Thank you. Thank you. You know, if you want to count or measure, of course, you know the difference between counting and what? Measuring. Okay? Like now, if you want to check my height, you're measuring, you cannot count my height. Am I communicating? You can only measure what? My height. Are we together? So, but you count what? It's not everything that is countable. There's some things that you cannot count. You only do what? Measure them. But how do you now do this measurement? You know, in different parts of the world, before now, the different parts of the world, they have their way of counting and measuring quantities. And they have different ways they do this thing. But irrespective of where you come from, there's always something that is common. In our mind, if something is three, is what? Three. You can call it anything you want to call it, but right in our mind, it's something is what? They are three in what? Number. They are what? Three in number. If they are four in number. But because of difference in language, culture, and a lot of things, how we now represent that thing we counted in our mind may do what? Differ. They may not be what? The same thing, the same way. But basically, in our mind, we counted the same thing. Okay, call a Chinese now. Call an Igbo person. Call an Italian, call people for different tribe, races and tribes, call them, line them up, and bring three stones and drop and tell them to count it. As they are counting it in their mind, they will count three. But tell them now to write down what they counted. They will write it in different what? Ways. Am I communicating? Yes. They will write it in different ways. But in their mind, it's the same thing there, it's the same three. Three is three. Am I communicating? So a number is an idea conceived in our mind. It's an idea we conceive in our mind on use or on how used in counting or measurement of what? Quantities. It's an idea conceived in our mind using counting or measurement of what? Quantities. Am I communicating? Am I communicating? Now, look up. If you're not careful, you will think that numbers and numerals are the same thing. They are not the same thing. Numbers now is that idea you have in your mind. But numerals is now how you do what? Represent that what? Number. Am I communicating? That's why they are nothing like Chinese number, English number, no. Igbo number, no. What you see, what you hear is this: Chinese numerals, Arabic numerals, Roman numerals. Because because this different this culture, these races, this tribe, they have their way of representing that number they have in what? In mind. Number is number everywhere. There's nothing like Chinese number. You may have Chinese numbering system, but number is what? Number. If it is two, it is what? Two. If it is two, it is what? Two. So numerals are set of figures, or call it digits as case may be, used to represent what? Numbers. Am I communicating? So, but we'll still go into numerals. Let's focus on what? Numbers. This is not the first time you heard you've you're hearing the term number. It's not new. So under numbers, we have basically two major categories of numbers. Two major categories of numbers. We have the real numbers and what? Imaginary numbers. We have the real numbers and what? Imaginary number. We have the what? Real numbers and what? And what? Imaginary number. We have the real numbers and we have the what? Imaginary numbers. Now, look up. Imaginary number goes beyond your normal counting, your normal measurement. This one is employed more in field of engineering and other applied what sciences. But the one that concerns us here in pharmacy is what? Real numbers. Am I communicating? Now, have you seen a number like this? They will say 2i. Have you seen something like this before? Good. This is an imaginary number. Actually, I represents square root of what? Minus 1. Use like a calculator, press square root of minus 1, it will tell you error. Square root of negative, square root of negative of a number, there is no answer in your calculator because it's not a real number. Okay, punch square root of minus 1 or square root of minus 2. Anyone is error because it's not a real number. Am I communicating? It's an imaginary number. Can you see the board from there? It's blocking you. Okay. Can you see it now? Yeah. Good. Is what? Imaginary number. But anything real number here, you can easily solve it with what this normal calculator you are seeing here. You can solve it with it. Am I communicating? Yes. Now, so this is, you see things like this. Generally, you see things like this. BR. Under real number, when imaginary number combined with real number, they form what is called complex number. Imaginary number combined with real number form what? This marker is not. Do you have a better one? Bring please. When you have imaginary number combined with real number, even this one, sir. All right. Thank you. When you have imaginary number combined with real number, you have a complex number. You have a complex what? Number. Let's see for example now. A real number may be A. This A can be 1, 2, 3, any number, okay? And this is BI. This coefficient of I here, which is B, can represent any number. Am I computing? If you have this A plus BI is a complex number. It can also be A minus what? BI is a complex number. If you fix up, if you put numbers here now, you can have things like 2 plus 3i, okay, or 2 minus 3i. This is a complex number. This is the real part of the complex number, and this is the imaginary part of it. Remember, I said that this I is minus root of minus what? 1. Remember, it's not minus 1, it's not minus root 1, it's root of minus what? 1, square root of minus 1. So this is, I just mentioned this for mentioning sake, for you to know that this number exists. Okay? But our focus is more on what? Real numbers. Okay? Real numbers. I asked this in examination just for you to identify it. It's not, there are calculations under this. There's calculation under it, but I don't want to go into that, okay? That one is in mathematics. It's in general mathematics. Those that actually did mathematics would have done this real number. Maybe especially, maybe this complex number. Maybe those that did further mathematics here. Who did further mathematics here? Who did further mathematics in secondary school here? Did you do this thing in your school? Anyway, let us not waste our time there. But let me just clean up. So now, let's now go over to what? Real numbers. When did this lecture start?
8:15.
Are you sure?
Yeah.
8:15?
Yeah.
Okay. So real numbers now. Here now, can you see the board there? Here now, under here now, you have there are different classification here, but I will focus on a group we call discrete numbers and continuous numbers. Discrete and what? Continuous number. If something is discrete, it means that that thing, from the name alone, is it stops at a point. Is this is what it is. It's not as if, or unlike continuous number that has no end. Like it's so like one as that one is one. Am I communicating? But if you start seeing things like 1.222 1.3333333, it has no end. You can only approximate it. How to get that? You can only do what? Approximate it. It has no end. 2.66666 has no end. 1.99, it has no end. The only thing you can do is to do what? Approximate to the number of significant figures you want, or decimal places you do what you want. But basically, things like 1, 2 is discrete. Am I completing? Yes. What of 1.5? Is it discrete? Half. Is it discrete? Or is it continuous? But is 1.5 continuous or discrete? Half. Check well from my definition. Do you think it's discrete or continuous? 1.5. What is 1.5 is 1.5, right? Yes. You can get half, get another half, get another half. It becomes what? It becomes what? 1.5. Is it continuous or discrete? Huh? Now look at 1.111. I said that 1.333. 1.3333 has no end. The 1.5, is it discrete or continuous? Why do you say continuous?
Why approximating it? Why approximating it? Present, the tree is now up to 5. So,
Here, I don't know what this one is. Which one are you talking about now? You said it's what? Why do you say it's continuous? I said that. Is it continuous or discrete? Why do you say it's continuous? Who has data? Check if 1.5 is continuous or discrete numbers for us.
Because it can be like it can be approximated to 1.5.
One is already 1.5 now. What are you approximating? What of 1.625? Is it discrete or continuous? Have you seen anything? Who has seen continuous? What rules did they give?
Divided into small parts, example 1.25 or 1.5. As if you decimal place.
Is what?
It's as infinite decimal places.
Infinite. Okay.
Yes, infinite decimal place.
Uh-huh.
Represent the points on the continuous scale.
So it's continuous. What of 0.5? Check 2. Is 2 a discrete number, a continuous number? No, you check 2. Is 2 a continuous number? What is it?
0.5
Is what?
is a continuous number.
Huh?
2 is an integer, which is a discrete
Okay, 2 is an integer, which is a what? Discrete number. Okay.
0.5 will confuse.
Why? What is they give?
I'm represented as a fraction 1/2. Its decimal representation makes it a continuous number. But they say that 2 is a continuous number.
That 2 is a continuous number.
number.
Confusion everywhere.
In fact, yes, I agree.
Really. See, I want to teach something. It's not everything. Wait. It's not everything you see online is true. Hope you know.
Yes.
Are you aware?
Yes.
And see, this was said that 2 is a discrete number. This was that 2 is a continuous number. Let me hear. Let's hear the reason.
2 is a continuous number. In mathematics, continuing to refers to the property of a set of sequence having no gaps or joins. Since 2 is a whole number and can be part of a continuous sequence, it is considered continuous.
All right, thank you. 2 is a discrete what? Number. Okay? It's a discrete what? Number. You know, all these things, they have different context. Different what? Context. With respect to what we are discussing here, in terms of being absolute, not an approximate. You know, absolute number you can count it. It has a definite magnitude, you can count it. This is 1 is what? 2 is also what? 3. You can do what? Actually do what? Count it. Communicating? You can count it. And based on that now, based on this context, 2 is a what? Discrete number. Now this 0.5, which is half. Can you count half? Can you count half? Can you? You can divide something into half, right? Get half. Get half. Get another half. Can you? Is it possible? And if you get half, get another half, it becomes what? Then you keep bringing half again. Can you? What of 1/4?
Yes.
Can you actually get it?
Yes.
It stops at a point. It stops at a 1/4 is actually, that is 0. What? 25, right?
Yes.
1 over what? 4. 0. It stops at a point. Is a by the time we go into fractions, we start hearing things like terminating decimal and recalling decimal. It stops at a point. Am I communicating? With this respect, where you can actually you can actually get 0.5, get 1/4 again, get another one again, get another one again, and make up to what? A whole, and keep getting, and you keep building, and unlike here you cannot do anything like that, because it's 1.33, it has no end. It is 1.3 until it joins. In fact, it has no end. There are nothing to join. Am I communicating? This is how it will continue. It will continue like that. It has no end. With that respect, I'll consider this a continuous. Consider this what? Discrete. Consider this what? Discrete. Consider this what? Discrete. But there are different concepts, just as we have here, where they are defining their own context and start calling 2 continuous what? Number. But based on what we're discussing here, 2 is a what? Discrete what? Number. Remember, we are not doing number here as number concept is so deep that if you start bringing up theories, and we may remain in number. This semester will end. Am I communicating? Number things concerning number is so deep. We are just taking this superficial to get you acquainted with what number what is. Am I communicating? Now, apart from this discrete and continuous, we talked about the words absolutes. I mentioned absolute now, right? Absolute numbers and the approximates. I mentioned it now. I mentioned absolute numbers and what? Approximate number. This one is countable, but this one is counted. This is count. This is applied in counting. It's more is countable. This one is what? Measurable. Am I communicating? You count this, you measure this. You count this, you measure this. Especially most numbers you obtain through measurements. If you use your ruler now to measure, maybe you measure 2 cm. You don't count 2 cm. You count 2 cm. You count 2 cm. You measure what? 2 cm. Am I communicating? Now, do you measure 2 oranges? You count 2 oranges. Have you seen it now? Have you seen it now? You count 2 oranges, but you don't measure 2 oranges. What you measure, you can measure 2 cm. So it depending on the unit in question. And this will give us there are different classification of numbers. And this will take us to another classification. We call it the one we call what is it called again? Abstract numbers and denominator numbers. Discrete, continuous, and absolute, approximate, abstract, denominator. Abstract, they don't have what? Units. Just 2. 2 is 2. But if you start seeing things like 2 cm, 2 kilogram, is now a denominator what? Number. Am I communicating? And most of the numbers you will do it in this course are what? Denominator what? Numbers. That's why if you solve any question without getting your answer, without putting your unit, you fail that word question. Because we are not talking about general mathematics now. We are talking about what? Denominate numbers. We are talking about what? Those numbers represent something, the correct quantity of drugs, quantity of ingredients. So you must put their what? Unit, because they are denominate what? Numbers. Am I communicating? Am I communicating? So denominate numbers, they have what? Units. And you must put that unit while writing them down. But abstract numbers, most of the numbers you encounter in your general mathematics are abstract numbers. It is that x is equal to 2. 2. Answer is what? 2. It has no unit. Unless in some topics where they want you to, maybe they are discussing some word problem that have to do with maybe transaction or tax or percentage and other things. You have to put your what? Unit. Am I complete? But most of the questions you solve in your general mathematics are what? Abstract what? Number. So I'm telling you this so you know that when any question you solve here, if you don't put your unit, you have failed that what? Question. Because let's assume you are working in a manufacturing outlet and you go and measure weight. You measure maybe weight of ingredient you want to use for preparation, and you don't put the unit. You just write 2. It's confusion. True of us. So how and most times it's not the person that weigh that will formulate. Am I communicating? Am I communicating? And yes, you may say the person should know now. He should use his sense to know that this thing should be weighed. It should be weighed. But in pharmacy, you don't assume. You don't do what? Assume. You must be sure of what you are what? Doing. Because if a doctor can make a mistake and kill and one person dies. But if a pharmacist or pharma technician make a mistake, millions can do what? Die. Because wherever the product goes to, that's where that's how far the havoc can go. until it is dictated and the drug and the medicine is what withdrawn. If not, it will keep killing. If it is if it's an error that can lead to death, it will keep killing people until they notice where as the drug is moving from Onitsha to Aba, is killing people. As it's entering different hospitals, is killing what people. Until and what before they even know what's going on, thousands would have died because the distribution would have gone to different places, and they may not know what is happening. Of course, you know that they will take the drug and go home and take. Some may die, they will say it's their village error, but they won't know exactly what caused it. Unless they start hearing that people dying anyhow, different places. That's going before they will even realize what is happening. Am I communicating?
Yes.
So that's why you should be very, very careful. And that's why, especially in this course, I don't take chances. Ensure you put your units, ensure you are very, very careful in everything you are solving. So now, I just mentioned different classes, categories of what? Numbers. Let me now go straight to numbers under real numbers. Remember I said real number, imaginary number. I mentioned discrete numbers, continuous number. I also mentioned abstract numbers, real numbers. I also mentioned absolute number and approximate what number. These are different categories based on different what concepts. Okay. Now, but our number focus is on what? Real numbers. Okay, real numbers. Now let me now under this, when you now come to real number, have you heard of number line? Can I claim this?
Yes, sir.
Have you heard of number line? Huh? Ndị edekwa WAEC. Ndị a na-ebe ka edekwa WAEC. What's going on? I'll ask you so you keep quiet and you're looking at me. This is your secondary school mathematics now. Even JS1, JS2. Two of us go to general mathematics, JS1 to JS2. You see number line there. So what is going on here? If I ask you, you keep quiet. Have you heard of number line before?
Yes.
Why keeping quiet on me now? It's like you say yes if you heard of number line. Now, you see something like this. Okay? You see something like this. These are the two infinities. Two infinities, okay? Two what? Infinity. This one is the negative one, and this is the positive one. Am I communicating?
Yes.
In the middle lies the what? Zero. In the middle lies what? Zero. So everything here is positive till infinity. Everything here is what? Negative. So you have here is -1, -2, minus what? 3, minus, sorry, don't mind me. So this is what? 5 till infinity. Here is what? -1, -2, -3, -4 till what? Infinity. Are we together? Now, this is what is called what? Number line. Now, real numbers are represented in what? Number line. But not all of them you can see. Am I communicating? It's not all of them you can see. As you can see, you can only see 0, 1, 2, 3, 4, right? So it's not all of them you can see, but they are represented in what? Number line like this. There are a lot of numbers in between these 2 and 3. Are you aware? There are lots of numbers in between these 2 and 3. Now, going down to real numbers, now you see the first one I want us to talk about is what? Integer. Integers. Integers are those numbers on the real numbers you can easily see, identify. Look at them. All these things here are what? Integers. Okay?
Yes, sir.
That one you can easily see represented full on the what? Number line. Am I communicating? Good. Look at them, integer. So 5 is an integer, 4 is an integer, 3 is an integer, 2 is an integer, 1 is an integer. Integer minus 1 is also what? An integer till infinity. So we have positive integers, we have negative what? Integers. Cool. The next one is natural numbers. Natural numbers. Natural numbers start from here. From 0 to positive infinity. Okay? So rational numbers comprise of positive integers and what? 0. Okay? From 0 to positive what? Infinity. All the positive integers and 0 are formed the what? Natural numbers. Natural numbers. From 0 to the positive what? Infinity. All the numbers 1, 2, 3, all the integers that are positive are natural numbers, including what? 0. Did I say that? Did I say that integers are that? Did I say that integers and natural numbers are the same thing? So natural numbers are subset of what? Integers. Are you aware? Yeah. Natural numbers are subsets of what? Integers. You know what I mean by subsets? Eh? Part of what? Integers. That's what I mean. Okay. Now another one is whole numbers. Whole numbers. Whole numbers are the positive integers from 1 to negative positive what? Infinity. So 0 is not a whole number. Am I communicating? Whole numbers start from here. From 1 to the positive what? Are we together? Yes. Are we together? Yes. From 1 to the positive what? Infinity. These are under, they are discrete numbers. Am I communicating? Yes. These are discrete what? Numbers. Confirm, they are discrete what? Numbers. Now, there's another set, another one I want to talk about. We have rational numbers. Do I need to start giving you examples of this again? No need, right? Because they are here. Okay? That's why I drew the what? Number line in the first place. That's why I drew the what? Number line in the first place. Okay. So, what are rational numbers? Rational came from ratio. Ratio. Rational came from what? Ratio. Okay? Which means and ratio is actually part of fraction, part of. Okay? That's why you see things like 2 is to 4. The thing that is saying 2 over what? 4. Am I communicating? So then what are rational numbers? Rational numbers are numbers that can be represented in the form a number that can be represented in the form a over b, or a is to what? B. Where a and b are integers. A rational number is a number that can be represented in the form a is to b, or a over b, where a and b are integers. A and b are integers. But a can be 0, while b cannot be what? 0. A rational number is a number that can be represented in form a over b or a is to b, where a and b are what? Integers. A can be 0, but b cannot be what? 0. If b becomes 0, it becomes undefined. Have you heard of undefined? Undefined fraction. Say that 2 over 0 is what? Undefined. Am I communicating? Yes. But 0 over 2 is what? 0. True of us? Yes. So b cannot be what? 0. But a and b are what? Do you know why they say that b cannot be 0? Because 0 is also what? An integer. True of us? Because if you say a and b are integer and stop like that, that means someone will go and put b to be what? 0, and you will not get any answer. It will become what? Undefined. Are we together? So I said that rational numbers are also fraction. They are fraction, okay? They are fraction, mainly common fraction, but they can be expressed as this: a is to b or a over b. Okay, this is how ratio is expressed normally, but because it's also fraction, it can be expressed as common fraction, like this: a over what? B. And I said that there are numbers that can be expressed in the form of a is to b over or a over b, where a and b are what? Integers. A can be what? 0, but b cannot be what? 0. Good. So with this now, do you think 5 is 5 a rational number? Is 5 a rational number? Eh?
No.
Is 5 a rational number?
Yes.
This is 5, right? This 5 now is this something as saying 5 over 1?
Yes.
Eh?
Yes.
So is 5 a rational number?
Yes.
So is a rational number. It shock you. Is a rational what? Number. What of 3? Is a rational. What of minus 2?
Yes. Yes.
Is minus 2 an integer? So minus 2 is a rational number too. Because minus 2 can be expressed as minus 2 over what? 1.
Okay, so you can actually say that all integers are rational.
Yes. They are what? They are what? Rational. Am I communicating?
Yes.
But not all rational. Is it all rational numbers that are integers? Not all rational numbers are integers. Not all rational numbers are what? Integers. 0.5. 0.5. Is it an integer?
No.
But it's a rational number. 0.5 can be expressed as what? 1 over what? 2. True of us? True of us? So it's a rational number. But is it an integer?
No.
All integers are what? Rational number. But not all rational numbers are what? Integers. Not all rational numbers are integers. Because 0.5 is not an integer, but it's a rational number. Are we together?
Yes.
Are we together? What of 22/7? Is 22/7 a rational number? Yes, it is. It is. But is it an integer?
No.
Now, the rational numbers that are not integers are found in between this place. Three of us. Where can we find 22/7? In between what? Where do you think we can find 22/7? It's not true. Between what?
Between 3 and 4.
Good. 22/7 can find between 3 and 4. Divide it now. Divide 22/7. Divide 22/7. 3 point what? It can be found between 3 and what? 4. But it's continuous. Is it discrete?
No.
Is it discrete?
No.
It's continuous. You can only do what? Approximate it. But whether you approximate it or not, the point that so far is 3 point something is found between what? 3. Because from here you start seeing everything here is 3 point, 3 point, 3 point. It's not. It's not. Everything in between here and here now is 3 point, 3 point, 3 point, 3 point, 3 point, 3 point, whatever, 3 point, whatever is lie between 3 and 4. 4 point, whatever lie between 4 and what? 5. 3 point means that it's less than 4 and it's above what? 3. That's the meaning. So 22/7 lies between what? 3 and 4. It's not an integer, but it's a rational number. It's not even discrete. It's continuous. So that means 22/7 is continuous rational number. It's continuous at the same time what? Rational. So it's a continuous rational number. Am I communicating? So you can also have continuous rational number. It is nothing but continuous number that are also what? Rational. This one is discrete rational number. 5 is discrete at the same time is what? Rational. Am I communicating? Am I communicating? Good. So that's what we mean by what? Rational number. So if I ask you question on rational number, now you can answer that, right? Right? Good. Okay. Before we move to irrational number, there are some numbers I want us to look at. There are some numbers I want us to look at. We have things like odd numbers, even numbers, prime numbers. So where do they lie? What is an odd number? What is an even number? What is a prime number? What is an odd number? Oh yeah, I'm listening. What is a prime number? Uh-huh. What is an odd number? Sorry. Is that what? Odd numbers are what? So any number that cannot be divided by 2 is an odd number. So any number that cannot be divided by 2 is an odd number. 1/3 can 1/3 be divided by 2? So is 1/3 an odd number? She's laughing. You say any number that cannot be divided by 2 is an odd number. And I ask you a question now. A whole number, you are getting closer to it. A whole number that cannot be divided by 2. Okay. A whole number is minus 3 and an odd number. Is minus 3 and an odd number. Is minus 3 an odd number?
Yes.
But she said that an number is a whole number. So is minus 3 a whole number? Is minus 3 a whole number? Someone said no. Okay, no problem. I Google what is an odd number now.
An odd number is a whole number that is not existing.
An odd number is what?
A whole number.
A whole number. Can someone check an under source? Is minus 3 a whole number? Why?
Minus is an integer, but is a positive, and what is positive, so what is
Positive what? Minus 3.
is negative.
So it's not a whole number.
Yes.
So is minus 3 an odd number?
Yes.
No.
Yes.
Is minus 3 an odd number?
Yes.
Google it now.
It's a negative odd number.
Good. I am driving to somewhere now. Listen carefully. You read something for us now that an odd number is a whole number. that cannot be divided, is not, that cannot be divided by 2, right? I agree. Now, I ask another question now. Is minus 3 a number? Is even no. And I also ask a question now. Is minus 3 an odd number? She said yes. So do you think that the division is correct?
An odd number is an integer.
God bless you, go far. It's an integer. Not a whole number. Because even this thing you say now, you can that thing, I'm not blaming you. I'm trying to point out what you see on internet. People can just upload anything they want there. But it says the whole number. Now I say that. Do you not know the correct one now? Yes. You don't know everything you see online is correct too. That's what I'm making. I'm not communicating. Yes. Not everything you see there is correct. So an odd number is an integer, not a whole number. A whole number start from here up. So an odd number is that's why you can also have a negative odd number, because an odd number is an integer. It's not a whole number. Whole number start from here. So an odd number is an integer divisible only by what? That cannot be by what? 2. Am I communicating? That is an odd number. So that's what I wanted to correct. Okay? Good. Now, so that means in that case, we can fix odd number here. We can align those ones under what? Integers. Are we together? We have their what? Odd number. What of even number?
Is an integer.
Good. So under here we also have what? Even number. So 1 is an odd number, 3 is an odd number, 5 is an odd number, minus 1 is an odd number, minus 3 is an odd number, minus 5 is an odd number, right? So for even number, minus 4 is an even number, minus 2 is an even number, and what have you. Are we together? Is 0 an even number? Is 0 an even number? Is 0 an even number? See your face. Hope you're not seeing mathematics in a different dimension, right? Is 0 an even number? Yes. Is 0 an even number? Yes. Why? It can be divided by what? Alright, take it up. Is 0 an even number?
Yes. 0 is an even.
Why?
Because it's a rational number.
I want to know the reason why. Why is 0 an even number? Fast. Our time is. It's divisible by what? 2. 0 divided by 2 is what? 0. No remainder. Okay? 0 divided by 2 is what? 0. No remainder. So 0 is an even number. Good. What of prime number?
An integer that is divisible only by itself.
Good. An integer that is divisible only by itself and what? So it's also under here, right?
Yes.
Prime number. Here, an example of prime number are what?
Yes.
No, from this one now.
5.
Is 1 a prime number?
Yes.
3 income?
Yes.
5?
Yes.
9?
Yes. No.
Minus 1?
Yes.
Are you sure?
Yes.
Are you sure? Minus 3
Yes.
is a prime number. Are you sure that 1 is a prime number?
Yes.
Confirmed.
No.
Why? Why is 1 not a prime number? So why is one not a prime number? Is one a prime number?
One was previously considered as a prime number, but currently it is not.
Eh? What do you have there?
Currently, one is a positive.
Is what? Our AI don't confuse. Our AI don't confuse.
Number one has to be one family. One is a unit.
Is it okay? Is that why it's not the prime number? The question is what is one a prime number? I will not answer that. You find out yourself and tell me in the next class. Is one a prime number? Why?
Prime number that exact
Is that what? Two factor, okay? I agree.
Since one only has one factor, doesn't mean
The requirement to be a prime number. Okay. Now with this now, let's look at irrational numbers. Irrational numbers. Ask.
You said that 9 is not a prime number.
Yeah.
But it can be very different.
What's a prime number?
It's a number that it's an integer that is divided by itself.
Only. Only. 3 can divide 9. 9 can divide 9. 1 can divide 9. So it's more than 2. The prime number has only 2 factors, itself and 1. Does it make sense now? So irrational numbers. An irrational number cannot be expressed as fraction. Okay? Number that cannot be expressed as fraction are what? Irrational numbers. You did sword in your year 1, right?
Yes.
Sword. This is the reason why they will tell you that. Have you heard of rationalization of sword?
Yes.
To rationalize a sword. This is why you rationalize a what? A sword. A sword is an irrational number on its own. Please, it's not every number you see under square root is a sword. Though. Square root of a perfect square is not a sword. This is not a sword. In fact, this is a rational number. Because square root of 4 is what? 2. Am I communicating? So this thing now is not a sword. So when people think that sword is this square, it's not this square that is sword. Am I communicating? Sword when a number that could not give is not a perfect square is under that square root sign, and okay, things like square root of is 49 a perfect square?
Yes.
Is this a sword? To give you what? 7. What of root 7? It's a sword. There's nothing you can do to this 7 again. So when a number that's not a perfect square is under the square root sign, it forms a sword. But there are some sword that are basic sword. There are some that you can still break down to the basic what? Sword. Okay? But sword is a what? Sword. So far that number is not a perfect square and it's under the square root sign is a what? Sword. Things like we have 8, square root of 8. Yeah? Whatever. Let me clean so I can explain this. I think we'll stop here. When I'm done with this, In our next class, we go over to what? Numerals. Okay. Now, see what I mean? Root 8, right? Root 8. 8 is not a perfect square. Okay? 8 is not a perfect square. It's a sword, but it's not a basic sword. You can say bring it, you can say what? Break it down. If you expand this now, it becomes 4 times what? 2, right? Which is certain as saying square root of 4 times square root of what? 2. Certain as saying square root of 4 is what? 2 times root 2, which is what? 2 root 2. 2 root 2, right? Good. You are brought it down to basic what? Am I communicating? But basically, it's a sword because it's not. This number now is an irrational number. It's a sword. It's not rational. It's an irrational. 8 is not a perfect square. 8 perfect square are things like 4 times 2 times 2 is what? 4. 4 is a perfect square. 3 times 3 is what? 9. 9 is a perfect what? Square. 5 times 5 is what? 25. 25 is the perfect what? Square. 6 times 6 is what? 36. 36 is the perfect what? Square. 7 times 7 is what? 49. 49 is a perfect what? Square. 8 times 8 is what? 64. It's a perfect square. 9 times 9 is what? 81. It's a perfect square. It's not a sword. 10 times 10 is what? 100. It's a perfect square. Am I communicating? Am I communicating?
Yes.
Now, so swords are irrational number. What of pi? Is pi irrational or irrational number? Pi, you know your pi now. Is pi irrational or irrational number?
Rational.
Some say rational, some say. What do you say rational number? Wait. What do you say rational? What is that pi is a rational number? Who else said that pi is a rational number? There are about 3 voices I heard here. Okay. What is it that pi is a rational number? That's where you got it wrong. Thank you. Sit down. In your secondary school, right? Hello. In your secondary school, you are told that pi is 22/7. It's a lie. It's not true. Pi is not 22/7. Now, okay, it's okay now. Okay, it's okay now. Let's do something now. It's okay. Let's do something. If you have a good calculator, call out for us the value of pi. If you have calculator, check the value of pi in your calculator. Wait, let's take it step by step. 3 point what? 1 person, please,
1415
Uh-huh.
92
Uh-huh.
654
654. Is that all?
Yes.
Then punch your calculator to tell me the value of 22/7 is what? Punch your calculator and tell me the value of 22/7. 1 person, please. 3 points.
142
Uh-huh.
85
Uh-huh.
7143
714. Is that all?
Yes.
Look at these 2 numbers. Are they the same thing? Do you know why you are told that in your secondary school, primary school, secondary school? Because they needed a number that is close to pi. So they stop here. And they say take pi to be what? 2%. Or 3.14, 22%, because they just stopped here. But pi is not the same thing with what? In fact, pi 22/7 is a rational number, but pi is an irrational number. It shock you. It shock you. Now listen. Now listen. If your number is discrete, you have no issue. You can easily know whether it's rational or what irrational. In fact, there is no discrete number that is irrational. Okay, rational numbers are discrete. Normal. There's no discrete number that is what irrational. That one has no issue. But when you come to continuous numbers, that's where the issue lies. Some continuous numbers are rational, some are not what? Some are irrational. So how do you now know a continuous number that is rational and and one that is what? Irrational. Now, this pi and 20/7, both of them are what? Continuous. But which one is rational and which one is what? Irrational. Now, if you want to find out, if you want for you to find out numbers, continuous number that is rational and one that is not what? Rational. The continuous number that is rational, they have a pattern. They repeat itself using a particular word pattern. Some may repeat itself by maybe 1.33333. Some digits may repeat itself by 1.3. Some may count like 5 digits and repeat itself all over again. If you see any continuous number in that form, it's a rational number. But if you see any continuous number that have no repetition, is scattered, it's an irrational number. Look at pi 3.14159 is scattered. There's no pattern, there's no repetition. But look at 20/7. Have you noticed anything?
Yes.
3.142857 billion. In fact, you know that you know that you are a calculator. Stop up did the approximation here.
Yes.
If you have your phone, put your phone in landscape. Let's take how far your phone can go. Put your phone in landscape and check 20/7. Let's see how far you can go with it. You know, the wider you know that this number have no end. The wider you are listening, the more value you see. Oh yeah, 3 point what? 1 person, please. 1 person, please. 1.
1428571.
Look at it. Look at it. 3.142857. It will stop. You start from 142,857 to stop. Start again. 142,857. Again. 142,857. It will continue that without end. In fact, if I divide it with like a calculator and I can start from here. If I divide 20% with that calculator, this is what you keep seeing until the end of this book. It has no end. That's why it's a continuous word number. But what matters is the pattern. See it. After 1, 2, 3, 4, 5, 6 digits, it will come back again. Again. So this number is a rational number, even though it's continuous. But look at pi. Pi has no end. Pi has no pattern. It's scattered. It's what? Yeah, and it's scattered.
Yes.
Am I completing?
Yes.
So pi is an irrational number. Why 20/7 is a what? Don't worry. When we do fractions, I will discuss this in detail. Talk about decimal, terminating decimal, recurring decimal, and all those things. I will discuss that when we go to what? I think that should be in our second topic. Okay? Good. So this is basically where I want us to stop in this farm card for today. So in our next class, we move over to what? Numerals. Any question? Any question? Any question? All right, in the absence of inquiries, I want to thank you for. Okay. Sorry, the course code is BDT 253, but the title is Pharmaceutical Calculation. Sorry, I didn't mention it. Pharmaceutical what? Calculations. That we call it FAMCAC. Just short form. But the course code is BDT 253. Are we together? All right, thank you very much for your attention. See you next time. God bless you.